In this video, we're going to be looking at binomial radical expressions. If you find this video helpful, please share, like, and subscribe. Thank you so much. Binomial radical expressions, sums and differences of radicals. Two radical expressions are like radicals if they have the same index and the same radicand. Okay, example of like terms. Let's say like terms, you're going to have 4x cubed, 11x cubed. These are actually called like terms. Unlike terms is just like example 4y cubed and then 11x cubed. Then you can see also, let's say 4y squared. So either the power or the variable are not the same. Okay, either the power or the variable. Look at this one. There is x in here. This one is the same variable, but they have different powers. So it's called unlike terms. Now let's look at some examples of like radicals. Example like radicals is say example for the cube root of 6 and then 11 cube root again of 6. So if you're going to look at this one, they have the same radicand and they have the same index. Okay, so in this case the radicand is 6 and the index is 3. Now let's also look at some unlike radicals. So for example, 4 cube root of 5, okay, or maybe let's say 11 cube root of 6, or maybe let's say 4 the square root of 6. So look at these two. Okay, the radicands are the same, but the indices are not the same. So they are actually called unlike terms. Simplify the following. Okay, let's look at letter A in here. Root of 63 plus root of 28. So we're going to look at it this way. 63 can be written as 9 times 7. Okay, and the other one, 28, can also be written as 4 times 7. So here we can now have our perfect squares in here. So let's simplify that. That's going to be 3 root 7 plus 2 root 7. Okay, the like radicals here is root 7. Okay, so simplifying further is going to give you 3 plus 2 is going to give you 5 root 7. Okay, so that's the answer to that problem. Okay, letter B. Let's look at letter B. The root of 150 minus the root of 24. So let's rewrite 150 into two factors that has a perfect square. So let's say 150 can be written as 25 times 6, and root 4 can be written as 4 and 6. Okay, so 25 is a perfect square, 4 is also a perfect square, so we can simplify that. So that's going to give you 5 root 6 minus 2 root 6. Therefore 5 minus 2 is going to give you 3 like terms. Just copy them, root 6. So this is the final answer to that. Okay, letter C. Let's look at letter C. It's a cubic one. 5 times the cube root of 2 minus the cube root of 54. Now let's continue to put 5 in here and copy this term because it's already simplified. But the cube root of 54 can be also written as 27 times 2. Now why 27? Because 27 is actually a perfect cube. Okay, 3 cube is actually the same as 3 times 3 times 3. Now that's going to give you 27. Okay, so let's continue with this one. So now here we go. 5 times the root of 2. Now the root of 27 is 3 cube root. So that's going to be 3 the cube root of 2. Therefore, finalizing it, 5 minus 3 is going to give you 2. And then here is the cube root of 2. Okay, that's the final answer. Okay, so let's look at the next one, letter D. Okay, so in this case, we're going to retain 6 root 3 because this is already simplified. But 75 can be 25 times 3. Okay, So here 6 root 3 is equal to 25. Square root is 5 root 3. Therefore 6 minus, okay, sorry, this should be minus. 6 minus 5 is going to give you only 1 root 3. But actually we don't normally write 1. We just say root 3 because it is understood already that there's 1 in front. Okay, so last but not the least, letter E, a cube root of 3x minus cube root of 24x plus cube root of 192x. So what we're going to do in here is to retain 8 cube root of 3x. It's simplified already. Here we're going to, let's say 24 is going to be 8 times 3x times 3x, why 8? Because 8 is a perfect cube. Here, the cube root of 192, we can break that out as 64 times 3x. Okay, I choose 64, I mean, because 64 is a perfect cube also. Okay, simplify. 8 cube root of 3x minus the cube root of 8 is 2. And here, the cube root of 64 is 4. Okay, 3x. So the common or like terms here are only the root 3x. Okay, 8 minus 2 is going to be 6. 6 plus 4 is 10 cube root of 3x. This is our final answer. Okay, a short reminder. Remember this in multiplying binomial radical expressions. Okay, so multiplication, we always use the FOIL method when it comes to binomial radicals. Conjugates such as root a plus root b and root a minus root b differ only in the sign of second term. If a and b are rational numbers, then the product of the conjugates produce a rational number. Okay, so let's look at this one. These are conjugates actually, and you're going to only have root a square minus root b square. That's going to give you a minus b. Now, another point to remember in here is this. You can use the conjugate of a radical denominator to rationalize the denominator. Okay, so keyword in here, when you say rationalize the denominator, okay, the operation that's involved in there is division. Okay, you're going to be doing division. When you're going to be saying rationalize, that's the key term, it means you're going to be dividing radical expressions. Okay, simplify, rationalize all the denominators. Okay, so let's look at letter A in here. Okay, so the first thing I notice in here is that the signs of the binomials are actually opposite. So this is just like our uh, special binomials, a minus b and multiplied by a plus b, the opposite signs. And the product of this is going to be a squared minus b squared. So with this in mind, I'm just going to get the first term in here, this one, and the last term. And I'm just going to square them with negative as the operation in there. So let's do that. 2 root 7, I'm going to square that, and then minus root 5 square. Okay, so simplifying it, this is going to give you, cancel that one. This is going to be 2 raised to 4 multiplied by 7 minus cancel this and 2. It's going to just be 5. So this is going to give you 4 times 7 minus 5. And 4 times 7 is 28 minus 5. That's going to give you 23. Okay. Okay, let's go for letter B. Okay, letter B, we need to have the conjugate in here. So the conjugate of this is going to be 1 minus root 3 all over 1 minus root 3. Okay, let's continue with the process now. So the numerator is going to give you 4 root 2 and then minus 4 root 2 and then root 3. Then we're going to have 1 square. Then we're going to only have here root 3 square it. So this is going to give you 4 root 2 minus 4 square root of 6 all over 1 minus 3. That's going to be cancelled out. So in here, it's going to give you 4 root 2 minus 4 root 6 over negative 2. Okay, let's break it apart. Let's break this down. This one, let's break it down. What I meant is that let's write it separately, okay? Root 2 over negative 2, and then this is minus 4 root 6, I mean, over negative 2. So they have the same denominator, so we can write it that way. So in here, if we're going to look at this one, I can actually cancel these two. Okay, this is going to be here, this is going to be 1, and this is going to be 2. Here, this is going to be still 2, and this is going to be 1. Now, let's be careful with the signs, okay? Here, it is going to be 2 root 2 over negative 2 is going to give you negative 2 root 2. Here, negative and negative is going to be positive. So that's going to give you 2 root 6 only. Okay? So this is our final answer in here. Okay, this is going to be plus. Okay, this is our final answer in here. Okay, let's look at letter C. Here's letter C. Okay, letter C is, okay, I can actually see again here, what we can see in here are the opposite signs of the binomial. So we can just simplify this as getting the first term, which is 3, and then square it, minus the second term, root 6, and square it. Simplifying it, this is going to give you 9 minus 6, and which is, it's going to give you 3 as your final answer. Okay, let's go for letter D. Here is our letter D. So in here, in this case, we're going to need again our conjugate. So our conjugate here is going to be 5 plus root 3 all over 5 plus root 3. Okay, continuing with the operation. So this is going to give you the numerator. Let's simplify the numerator. So that's going to be 2 times 5. It's going to give you 10 root 3. Then next is going to be plus 2 root 9. Okay, then next is going to be just plus 5, and then it's just going to give you plus root 3. Okay, the denominator is just going to be 5 square minus root 3 square. Okay, now let's look at this one. This has actually these are common, okay. This one we're going to simplify this part. Okay, so let's continue with the process. So 10, we're going to 10 root 3. I'm going to put that next to it, plus root 3. And then we're going to simplify this one. That's going to be plus 2 times 3. Square root of 9 is 3, plus 5. So over 25 minus, cancel these two together. It's going to give you only 3. Okay, continuing the process, so that we have 11 root 3 in here. Okay, this is going to give you 6. This one, it's going to give you 2 times 3 is 6. 6 plus 5 is 11. Okay, so that's going to give you 11. All over 25 minus 3 is going to give you 22. Okay, so here, let me break it out again, just as I did earlier. 11 root 3 all over 22, and then plus 11 over 22. So our final answer in here, we're going to have 1, this is 2. Here, this is 1, this is 2. So the denominator is 2. Okay, so the answer here now is just going to be root 3 plus 1 over 2. This is our final answer. Okay, let's go for the next one, letter E. Okay, letter E, this is very nice. We're just going to do the FOIL method in here. Okay, so that's going to give you This one and this one is going to give you 2, then 8, and then square, right? So that's going to give you minus 4 times 2 is 8 root 8, and then minus 6 root 8, and then it's going to give you plus 24. Okay, so this is going to be cancelled out, so that's going to give you 2 times 8 minus 8 root 8 minus 6 root 8 plus 24. Okay, I just write everything. I just actually simplify that part. So that's going to give you 16. Okay, negative 8, negative 6 is going to give you negative 14 root 8 plus 24. Okay, let's put that here. 16 plus 24 is going to give you 40 minus 14 root 8. Now, we're not done yet here because we still have to simplify this one. So 40 times 14. Now 8 can be presented as 4 times 2. Okay? So that's going to give you 40 minus 14. The square root of 4 is 2. That's going to be multiplied by 2 and then root 2. Okay, so the final answer here now is going to be 40 minus 28 root 2. Okay, this is your final answer in there. Okay, let's go for letter F. Letter F. So here we can infer from here that we needed the conjugate again. So this is going to be 2 minus root 3 divided by 2 minus root 3. Okay, let's continue with the process. So that's going to give you 2 root 5. Okay, then minus root 5 and then root 3. Okay, this is just going to be 2 square minus then square. Okay, let's continue. So simplify that part. That's going to give you 2 root 5 minus root 15. Okay, simplify this part. That's 4. Simplify this part. It's going to be 3. So you're just going to be left with 2 root 5 minus root 15 all over 1. So since the denominator is 1, we normally don't write it this way. Instead, we just write the numerator 2 root 5 minus 15. The root of 15, I mean. Okay, so that's the final answer to that. This is all for the lesson on these binomial radical expressions. If you find this video helpful, share, like, and subscribe. Thank you very much.